Yeah, now it will be audible. Please tell me if it is audible. Now it will be audible. Okay. Yeah. So guys, what I was telling is, without audio, DBMS is a simple subject. Okay. You should not miss even a single question in DBMS. If you miss a question in DBMS, it means that everyone else will be able to answer it. See, there are three things that may happen in a gate. Okay. So if you answer a question correctly, it will place you here. And if you leave out a question, it will place you here. But if you give a wrong answer, it will place you here. There are three levels in gate. Every question puts you at three levels. Answer it correctly, you will be here. Answer it. Don't answer it, at least you will be here. If you answer it wrong, you will be here. And DBMS is a very simple subject that you can answer all the questions in DBMS. For the past, I have been teaching since 2008. So how many years are there? 18 years. For the past 18 years, I didn't miss a single question in DBMS. Not a single question. 18 years, not a single question in DBMS. Okay. It is such a simple subject that you should definitely score well. Okay. Okay. And in this subject, I have invented many things. You can't find this explanation in any textbook or in any lectures, video lectures. Okay. So see this. What am I saying is normalization, it is used to eliminate or reduce redundancies in database if two or more independent relations. If two or more independent relations means tables. Okay. If two or more independent relations are stored, if two or more independent relations are stored in a single relation, in a single relation, in a single relation, okay, then it forms redundancy. Then it forms redundancy. Let us say there are three tables. Okay. Let us say there are three tables. Okay. Let us say there are three tables. Table number 1 is SID comma SName comma date of birth. So this is the student information, right? And table number 2 is CID, course ID. See, SID means student ID, student name and date of birth. And the table number 2 is course ID, course name, and let us say instructor. Okay. And table number 3 is SID, CID. So let me write the names also. Okay. So this is student table. This is student table. And this is course table, which will contain all the information about the courses. And this is enroll table. Enroll table means how many people have enrolled in a course, right? So SID, CID, this student has enrolled in this course and has paid a fee of something. Here SID can be the primary key because SID, student IDs are all distinct. Here course ID can be the primary key, but here SID and course ID, SID cannot be candidate key, the primary key. The reason is a same student may enroll in different courses. That is why student ID may repeat. Now CID also cannot be a primary key because a single course may have multiple students. Therefore CID is repeating, so it cannot be the primary key. So SID, CID together will be the primary key, right? Now let us say instead of having these three tables, we have stored entire information in two tables. Okay. Let us say we have stored entire information in one table. Okay. So let us say the table is SID. All three attributes of each table are present in the single table. CID, CName, instructor, SID, CID and fee. SID, CID and fee, right? I'm just dividing them, not by table, just for the sake of this understand. Okay. Now let us say there is a student S1 and his name is A. Okay. And his date of birth is 1990. 1990. So let us divide them according to the tables. Okay. Let us divide them according to the tables. Okay. So let us say this is a single table, but I am dividing according to the tables. Okay. Now let us say there is a student S1 whose name is A and his date of birth is 1990. Okay. And his course ID is C1. He has registered for a course called C1 and the name of the course is, let us say, database, right? And the instructor of the database is, let us say, fourth. Okay. Now SID, CID, you don't have to mention them because already SID is there and already CID is there. So you don't have to mention SID, CID. You can just mention P. So I'm removing that and I'm just mentioning P, right? Now let us, what is the meaning of it? This student has registered in this course for some fee, okay, 1000, some fee 1000, okay, okay. And then similarly, there is a student S2 whose name is also A, right? And whose date of birth is 1990, and he has registered in course C1, which is DBMS course, and it is taught by Korth, and let us say the fee is 1000, right? Now let us say S3 is a student whose name is B, and whose date of birth is 1998, and he has registered for a course C1, which is database, which is taught by Korth, and fee is 1000, right? And let us say the same student S3 registered in different course, S3B 1998. He has registered in a different course C2. Let us say the course is algorithms and the instructor is Foreman, and then the fee is 2000, right? And let us say S3 has registered in one more course. The same student S3 has registered in one more course, which is OS, which is taught by Galvin, and the fee is 3000, right? Now what happens, what has happened here? When you have represented all the tables in a single table, there are a lot of redundancies. Right? Now if you observe it, the student name is repeated 3 times. So whenever the student has registered for a course or for a different course, his data is completely added. This data is repeated 3 times. There is obviously redundancy. Now whenever a student registers for a course, that course information entirely is getting added. 3 times, right? How many our students register for the course, those many entries we are getting it, right? So that is why there is a problem here. What is the candidate key here? So candidate key cannot be S1, candidate B cannot be S name, it cannot be date of birth, it cannot be CID. It is repeating. So a single attribute cannot be a candidate key. But what can be the candidate key? If I combine SID and CID together, they will be unique. S1, C1, S2, C1, S3, C1, S3, C2, S3, C3. They are repeating. Right? Now, this is the problem with keeping many tables in a single table. Right? Now, what are the problems because of redundancy? Let us say problems because of redundancy. Problems because of redundancy, right? So what are the problems we will get? These problems are also called as database anomalies. Anomalies means inconsistencies. Database anomalies, right? Now there will be insertion anomaly. Insertion anomaly. Don't write the notes. Vasudha will be writing the notes and providing you the complete notes. So insertion anomaly means what? If I have to insert a course information, I cannot insert it unless some student has registered for it, which means I cannot have courses in which which are not having a single student, right? And similarly, if I have to add a student, I cannot add a student unless he is registered in some course, right? So that is called insertion anomaly. And the next one is deletion anomaly. Deletion anomaly, right? Now the problem is, if I have to delete, let us say C1 course, then I have to delete this, C1 course, because of which S1 and S2 are lost. S3 also one entry is lost, even though other entries are there. S1 and S2 is getting lost. That is called deletion anomaly, right? And the next one is update anomaly. The problem is, now that the single information is present at many places, right, you cannot make sure that every place it is updated, right? What do I mean? Let us say date of birth of S1 is entered, let us say date of birth of S3 is entered wrongly. Now you want to update it. Now if you update it here, there is no guarantee that it is updated in all the other entries where S3 is present, because database may be very huge and finding out all the repetitions and removing them is going to be hectic, right? So these are called update anomalies, right? So these are all the anomalies, they're all the problems that we have when we are having many tables in a single table, right? So when do we don't get anomalies is when there are 0% redundancy. When there is 0% redundancy, 0% redundancy in the database, then it implies there are no anomalies, no anomalies, no anomalies. Okay, okay. Now what should we do? In order to overcome these anomalies, we should divide a bigger table into many smaller tables. That is called normalization. What is normalization? Dividing a bigger table into smaller tables is called normalization. Okay, so let us see what is normalization. Decomposition of a relation. I started using coloring pens. Decomposition of relation, decomposition of relation R into sub-relations. Decomposition of relation R into sub-relations R1, R2, so on Rn, so on Rn, to eliminate or reduce redundancies. Right? So what is normalization? Decomposition of a relation R into sub-relations in order to reduce R, right? This is called, okay, normalization. Decomposition of relation into many small relations to eliminate redundancy, you can say, is called normalization. Okay, okay. Now, what is the normalized database? For the above table, how can we normalize it or divide it so that we don't get redundancies? Simple, keep the student table separate, course table separate, and enroll table separate, right? So, in the student table, I will write SID, name, and date of birth. Okay, this is the student table. Okay, and then this is the student table, and then course table. Course table is, we have course ID, course name, and instructor. Course ID, course name, and instructor. Course ID, course name, and instructor. And then we have enroll table. Enroll table. So in enroll table, we will have which student has enrolled for what course. SID, CID, and then P, right? From the before table, we can write like this. There are 3 students in the earlier table, S1, S2, S3, right? And then there was some name, there was some database, there was some date of birth, and then course ID, C1, C2, C3 course is there, right? And then there were some course names and there were some instruction names. Now, some student has enrolled for some course. How are you going to maintain it? Student S1 has enrolled for C1, student S2 has enrolled for C1, student S3 has enrolled for C1, student S3 has enrolled for C2, student S3 has enrolled for C4, right? Now, by writing like this, there will be no anomalies. If you want to add or delete or update student, you do it here. Add or delete or post student, you do it here, right? And now these are something called as foreign keys, which I will tell you later, okay? So SID is a foreign key referring to the primary key of student table. CID is a foreign key. You know, SID is the primary key here, okay? Let me use a different pen. So SID is a primary key here, CID is a primary key here, and SID is a foreign key. This is a foreign key. About foreign keys we will see later, okay? Right now they are not required for the concept of normalization. Later we will see that, okay? Okay. So this is called normalized database design. Got it? Got it? Now the next one is functional dependency. Now the next one is functional dependency. Functional dependency. X comma y be some sets of attributes. X comma y be some sets of attributes of relation R. Relation R. Okay, what is a functional dependency? X comma b be some sets of relation attributes of some relation R, of some relation R, right? T1 comma T2, T1 comma T2 are any tuples. T1 comma T2 are any tuples of R. T1 comma T2 are any tuples of R, right? Now X determines Y. X determines Y is called, X determines Y is called functional dependency. Functional dependency. F determines Y is called functional dependency, okay? If I write like this, some set of attributes determines some set of attributes, that is called functional dependency. X determines Y functional dependency is implied on relation R, which means table R, if T1 dot X is equal to T2 dot X, then T1 dot Y is equal to T2 dot Y. t1 dot y is equal to t2 dot y, t2 dot y, right? Now what is the, I will give you examples, you just tell me whether they are functional dependencies are applied or not. Okay, so what is the condition we need to check? Let us say this is x, this is y. Okay, now this is x1 y5, x1 y5, and this is again x1 y5, and this is x2 y2, and this is x3 y2, this is x4 y4, this is x2 y2. Okay, now if I say x determines y, will it hold on this table or not? How do you check it? Just go to all the rows where x is same and then their y should be same. For example, x1 is repeating here, x is same and y is also same, y5 y5, right? Now x2 is repeating here and y is also same, y2 y2. x2 is repeating here and y is also same, y2 y2. Therefore we can say that x determines y is implied on this relation R. Can you tell me whether y determines x is implied? Come on to the Telegram channel, and on the Telegram channel you try to answer. In Telegram channel you try to answer. Come to Telegram channel. Okay, so what did you get? So look at the y values wherever they are repeating. y5 is repeating here, so x1 is same. But then here y2 is repeating, but the value of x's are different. Therefore, y determines x does not hold. Okay, if I put a x, let me put a x with other pen. So this doesn't hold, this holds. Right? Okay. Now I'll give you a table. Tell me whether the following dependencies are holding or not. Okay. मुझे मिलके लगा है ये, तुझे ढूंढ रहा था मैं, मुझे मिलके लगा है ये, तुझे ढूंढ रहा था मैं, तुझ में है कुछ ये सुहासा, जिसके खातिर मैं था जगा सा, आजा मेरे बाहों में आजा रे, आजा रे माही आजा रे, तुझ में है कुछ ये सुहासा, जिनके खातिर मैं था जगा सा, आजा मेरे माही आजा रे, माही give me a pen. माही आजा माही आजा रे, तुझ में है कुछ ये सुहासा, जिसके खातिर मैं था जगा सा, I'm just drawing the lines. There is no significance for these lines, just to be clear with which S matches with which VA, right? Mahi, Mahi. C1, C2, C3, C3, C4. 1 minute. That's what writing these tables is a confusion, and we need the exact table, otherwise the example will not work. S1, 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 A, C1, C2, C3, S2, S2, S3, B, 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 C, C3, C4, C1. C3, C4, C1, and then C2, C3, C2, C3. Okay. Now tell me whether these functional dependencies hold or not. SID determines SName, and then SName determines SID. Answer in the Telegram channel or in the YouTube chat. Tell me whether this holds. Okay. Okay. So SID determines SName. Let's see whether it is holding or not. Whenever SID is repeating, SName is same. Whenever SID is repeating, SName is same. If it is not repeating, they may be same or not, we don't care. Whenever it repeats, we want the S name to be same, so this is valid. Now what about S name determines SID? See this. Here S name is repeating, A is repeating, and SID is same, no problem. But here S name B is repeating, S2 is same, no problem. But then here S name C is repeating, but SID is not repeating. SID is different. For same S name values, we are getting different SIDs. Therefore, this is not valid. This is not valid, right? So that is about functional dependencies. Now let us see types of functional dependencies. Okay. Let us see types of functional dependencies. Okay, let's type types of functional dependencies. Types of functional dependencies. Okay, what are the various types? First one is trivial FD, trivial functional dependency. So what is trivial functional dependency? X determines Y is trivial. X determines Y is trivial functional dependency of R if X is a superset of Y, which means if X is determining only some of the attributes of itself or all the attributes of itself, then it is trivial. So what are the examples? If I write like this, SID determines SID, it is trivial because SID is already there. What is there to determine? Now if I write like this, S name determines S name. So S name is, if the S name is given, it is giving us S name. So what is it? Now SID, S name together determine S name, right? Now again see this, S name is here, we already have its value, then why are we asking the value of S name again? It is trivial, right? Now similarly SID S name, SID S name determines SID S name. We already have SID S name values, and why are we using it again, right? Now the second one is non-trivial FDs. Non-trivial FDs. Non-trivial FDs. Okay. Non-trivial FDs. What do I mean by non-trivial FDs? There is nothing intersection between left side and right side. Completely different. Okay. So X determines Y is non-trivial. So DBMS is going to be interesting from now on. You will love the classes. DBMS is going to be very, very interesting from now on. We are just ending up the theory and then we will start solving hell a lot of problems. Everything, see, the way I explain anything is with lot of problems. If I explain you theory, you may not be able to understand it. But if I do 10 questions on that theory, because of working on the questions, you will be able to remember the theory. And trust me, I can't wait. I love teaching DBMS and I love all these topics. I love it. Okay. So I was like waiting. When is DBMS going to start? When am I going to teach? I love doing this. Okay. You will love it. Don't go anywhere. You will love it. Okay. Fine. Now the thing is non-trivial FDs. x determines y is non-trivial FD if x intersection y is equal to phi, which means there should not be anything common. For example, SID determines S name and SID CID determines S name, right? Now there are something called as semi non-trivial dependencies, right? There are something called as semi non-trivial dependencies, which means there will be some intersection. Actually, trivial and semi non-trivial functional dependencies we don't use in any of the questions. We use only non-trivial functional dependencies, but then still it is there in the theory, so I have to tell you that. Okay, so it is a combination of trivial and non-trivial. It is a combination of trivial and non-trivial dependencies. So it is a combination of both. Right? So for example, if I write like this, SID determines SID S name. See, you can split the right hand side, right? You can always split the right hand side. Remember this. If right hand side is having more than one attribute, you can definitely split it. I can split it like this. SID determines SID, this part, and then SID determines S name. So actually this is a combination of two things. This is trivial and this is non-trivial. Right? Now for example, if I have SID CID determines CID S name, it can be written as SID CID determines CID and SID CID determines S name, right? Now there are some rules over FDs. Okay, we'll quickly finish those rules and we will start the problems. Okay, we will quickly finish those rules and we'll solve the problems, right? Just hold on for some time. Okay. Okay, now let us see Armstrong rule over Armstrong rules over FDs. Armstrong rules over FDs. So if x comma y comma z are some attributes, if x comma y comma z are some attributes, sets over R, if x comma y comma z are attributes over R, first one is reflexivity, right? So reflexivity is trivial FD. So what do I mean by x determines x is reflexive? And the second one is transitive. You already know all these, okay? These are 10th class mathematics, reflexive property, transitive property, all this. So what does that mean? If x determines y and y determines z, then x determines z, okay? And then augmentation. Third one is augmentation. Augmentation means if x determines y, then you can augment something on both these sides. Xz determines yz. So what have we added? Z determines z we have added, which is trivial. So we can do that. Okay. And the next one is split rule. Fourth one is split rule. Split rule. Okay. So what do I mean by split rule? By split rule, if x determines yz, then x determines y and x determines z. X determines y and x determines z. And the fifth one is merge rule. And the fifth one is merge rule. Merge rule. So in merge rule, if x determines y and x determines z, the same opposite of it. So this split and merge rule are opposite of it. If these are given, you can write like this. Okay. Then x determines yz. X determines yz. Right. And the next one is attribute closure. Attribute closure. So what is attribute closure is, we will take some attributes and we will try to find out what are all the other attributes that can be determined by these attributes. Okay. So that is attribute closure. So attribute closure is X is some attribute set. We'll take some attribute set of relation R, attribute set of relation R, then X plus is equal to set of X plus is equal to set of all attributes, set of all attributes which can, set of all attributes which can be determined, by x. So x plus is set of all attributes which can be determined by x, right? So I'll take an example and explain you closure. So once you understand this closure, we are very close to solving very difficult problems, right? You are going to love it like anything. And trust me, whatever I'm going to explain here, you will not find in any textbook, in any video lectures. If you can find this explanation anywhere, you will get the full fee refund. Okay, try to prove that someone has explained these questions in this way. I'll give you full fee refund. Okay, so let's take break for 5 minutes, not 5 minutes, 3 minutes, and then we will continue. Don't go anywhere. Okay. Okay. Okay, fine. So let me give an example. This is very important. Once you understand it, you will be able to do the questions without pen and paper. Trust me. Once you understand what I am doing, this one, attribute closure, without pen and paper, you will be able to answer many questions in GATE. GATE questions are very, very simple, but in the class, we are going to cover we are going to do a lot of difficult questions. Valde Raman ra? ఎక్కడికి వెళ్ళారు? Okay, fine. So, let's say given FD set of relation R, given FD set of relation R, given FD set of some FD set is given. A determines B, C determines D. Don't say derives, okay? That is in TOC. That function, that productions are in TOC. Here it is determines, okay? Ninne ra ಜ್ಞಾನ. Okay. So A determines C, C determines D, AB determines C, BC, BE determines C, EF determines G. Okay. Now find out A closure, which means what are all the attributes that can be determined by A using all the rules that we have seen. Anyway, we are not going to apply all the rules. It is very simple. A plus will contain A. Now A is determining B, so I'll write B. Now C is not there. AB is here, which is determining E. AB is here, AB is here, which is determining E. And B is here, B is here, so I can add C. Now C is here, I can add D. Now EF is not there, right? So again see this, A is here, I added B, C is here, I added D, AB is here, I added E, B is here, I added C, F is not there, so I cannot add G here. F is not there. So A plus is A, B, C, D, E, right? Now what about AF plus? If I write AF plus, what is this, right? So AF plus will contain AF. This is actually set of attributes. You have to use set representation, but that is not required, okay? No, it is not a theoretical exam. So AF is going to contain AF and A is determining B, right? Now we have AF and AB is there. So AB is determining E and B is there. B is determining C and then EF is there. EF is determining G. So A, B, C, D we didn't get a C determines D. A, B, C, D, E, F, G. ఎవరైనా తప్పు చేసి చెప్పండి చూస్తున్నారా? Okay. Now okay. Now see this. Next one is, let us say BE plus. BE plus. Okay. So one thing you have to observe here is, I'll tell you that later. Okay. Candidate keys and super keys. Now let us say BE plus. BE plus. So BE plus is going to be BE. Now B is here, because of which we get C, and because of C we get D. A is not there, so we don't get B. I mean B we already got. This FD is useless because AB is not there, and here we have BE, so C is added, and we don't have EF, so BECD is the functional dependence. So what you can do is simply you can write like this: A determines ABECD, right? Because its closure is that, right? And AF determines ABCDEFG, and BE determines BECD. BE determines BECD. Okay. Okay. Now let us talk about super keys and candidate keys. We are almost reaching the end of the theory, and then it is going to be extremely interesting. Trust me, it is going to be extremely interesting. I am going to show you some method which is not there in the textbook and no one has taught it so far, and this is called RBR's method. Okay, just hold on, we are at the end. Okay, super key. Super key. Okay, you know already super key. What is a super key? What is a super key? It should be able to determine everything, right? So X is some set. It need not be minimal. Minimal super key is candidate key, right? We discussed it. X is some set of relational schema. X is some set of relational schema or X is some set of relational schema R. Now X is superset of R. X is superset of R if X plus must determine all attributes of R. If X plus can determine all attributes of R. If X plus can determine all attributes of R, right? Now let us see this. Let us take an example. There is a relation with attributes A, B, C, D, E, F. So now let us say functional dependencies are AB determines C, C determines D, D determines E, E determines F, F determines B. Okay, these are the functional dependencies. Now I want you to find out what is AB plus. What is AB plus? What is AB plus? Right. So what is AB plus? B, you have first AB will come. Always whenever you apply closure, the same attributes will come. Now AB determines C, so I get C. C determines D, I get D. D determines C, I get E. E determines F, I get F. F determines B, B is already there. So A, B, C, D, E, F, I got everything, right? Now this is definitely a super key, right? So this AB plus is definitely a super key. If it is minimal super key, we can call it candidate key, right? Now, how can I say whether it is minimal or not? If I remove any attributes from it, right, they should not become a super key, right? So what is minimal super key? If I remove something from this, they should not become a super key. For example, let's see A plus. A plus is A only, and I will not be able to derive anything. Let's see B plus. B plus is B only. I will not be able to derive everything. Therefore, A and B are not super keys. So AB is the minimal super key. So since this is minimal super key, and తప్పు చేసి చెప్పండి. Since this is minimal super key, this is candidate key as well. Since this is minimal super key, this is candidate key as well, right? Now if I write ABC, see already AB is able to determine everything. ABC will also be able to determine everything, right? Now this is a super key because it is determining anything. But is this minimal? This is not minimal because if I remove C, AB is a super key. So I'm getting a minimal one. This is not the minimal. I'm getting a minimal one. Therefore, it is just a super key and it is not minimal super key. Therefore, it is not candidate key, right? Now, let's see BC plus. Now, BC plus will get B. A is not there. C is there. So, we get D. D is there. We get E. E is there. We get F. F is there. We get B. We are not getting A, right? So, this is not a super key. And if it is not a super key, it is not minimal super key also. So, it is not candidate key as well. Candidate key as well, right? Now, we know already candidate key, but we will just take some definition of it, okay? Candidate key, right? So do one thing. I will give you 2 minutes of time. I know that you might not have revised yesterday's class, the last class. Just go there and revise what is super key and what is candidate key and come back. I will explain with a different definition. Now we are going to change the definition a little bit. You please revise the notes and then come back in 2 minutes. I am giving you 2 minutes time. Okay. కొంచెం సేపు లాస్ట్ లో okay. See, my team is very excited. Come here, guys. So these three people have no. Come here, guys. So this is Chaitran. So Chaitran is my weapon. This time he is going to get AR 1, okay, or at least single digit rank, right? Come here, Tara. And this guy is everything to me, Nana, okay. And this time he is going to get AR single digit rank, I can tell you, right? And this guy is Vishnu, he is everything to me. And this guy is also going to get a single digit rank. Now these three people have helped me in proving that my method is right, okay. So I have tried a different method, and these people have solved hundreds of questions to find out a mistake in my method, and they are able to find mistake in every other lecturers were wrong, right? So this method is going to be amazing, okay guys. Yeah. Okay, so what is candidate key? So what is candidate key? Candidate key is minimal super key, right? Candidate key is minimal super key, right? So X is candidate key. X is candidate key of R. I'm going to write some conditions. These are all simple. Of R if X is a super key. If it has to be candidate key, it has to be super key, which means it has to determine all the attributes of relation R. S is super key of R, which means if I find out X plus, I am supposed to get all attributes of R. All attributes of R. And second one is no proper subset of R, no proper subset of X, which means if I take any proper subset of X, that should not be a super key. No proper subset of X is super key of R, right? For all Y, for all subsets of X, Y plus does not determine all the attributes of R, does not determine all the attributes of R, right? What is the meaning of it? X is a super key and it will become a candidate key only if none of its subsets are determining all the elements of all the attributes of relation R, which means subset of X should not be a super key. That is it. Then only it will be minimal and it will be called a candidate key, right? So these two, right? Very good. Now we are going to start. Ready? Excited? How's the Josh? How's the Josh? What's the aim? What's the aim? Good, good. So now let's see the problems. Okay, or A, B, C, D, E. A, B determines C, C determines D, B determines E. Okay, B determines E. Now the question is find all candidate keys. Find all candidate keys of the relation R. Find all candidate keys of the relation R, right? So you have to use your intuition. So let me tell you one thing. How I have designed this problem is, how to solve this problem is, you are not going to find this problem anywhere in any textbook, this solution. No one in world has done the way that I did it, and whatever other way you follow, that will give you wrong answer. I can prove by taking every other's videos to show that they are wrong. Okay, fine. Now let's see the candidate keys. So guys, tell me one thing. If I have A, B, C, D, E and forget about functional dependencies, how many candidate keys are possible? Forget about functional dependencies. We have 5 attributes A, B, C, D, E. How many functional dependencies are possible? How many functional dependencies are possible? See, I can choose this to be in the candidate key or not. Choose or not. Choose or not choose. Choose or not choose. Choose or not choose. It is going to be 2 power 5, that equal to 32. But you have to subtract 1 from it. What is the 1? In this, null is present. See, what is set of all subsets of it? Set of all subsets of it. How many subsets do we get from A, B, C, D, E? 2 into 2 into 2 into 2 into 2, which is 2 power 5. But then you have to do minus 1 because 5 is not a candidate key, right? What is the other way of doing? The reason why I taught you combinatorics before doing DBMS is because we are going to extensively use combinatorics in DBMS, especially when it comes to normalization. Okay. So guys, normalization and transactions, everywhere we are going to use combinatorics. Okay. Now, what is the other way of proving it? From 5 elements, I can choose 0 element. From 5 elements, I can choose 1 element. From 5 elements, I can choose 2 element subsets, 3 element subsets, 4 element subsets, and 5 element subsets. Okay. So 5C0, 5C1 plus 5C2 plus 5C2. So you have to delete this. We know that the sum of entire thing is 2 power 5 and you are going to subtract 1 from it, which means there will be no 0 element candidate keys, right? Therefore, you have to write down 34 attribute sets. Huh? Okay, yeah, sorry. We have to write down 31. Thank you. We have to write down 31 attribute sets, 31 attribute sets, and we have to find out whether they are candidate key or not, which means 31 closures we have to find out. But then if you use your intuition, you don't have to do so many cases. With only few cases, you will be able to do it. Okay, see this, see this. Now, see if anything is missing from the right hand side. What are the attributes? A, B, C, D, E. Here I have C, D, E. AB is missing. There is no way you can determine AB if AB is not present in the right hand side. Therefore, every candidate key should contain AB. That is the first point, right? So what is it? Every candidate key should contain AB. Write it down. Okay. Now, okay, every candidate key should contain AB. Now you should ask a question. Is AB a candidate key? Right. Therefore, find out AB closure. Okay. Find out AB closure. Now, what is that we are getting? If I get AB closure, I get AB and because of AB I get C, because of C I get D, and then because of B I get E. So ABCD I got. So ABCDE I got. Therefore I will write candidate keys here. Candidate, one of the candidate keys is AB, right? Now once you see that AB should be present in every candidate key, therefore below AB there will be nothing. So if you see one element candidate, one element subsets, there is no way we can get. The reason is A or B cannot be, see, candidate key should definitely contain AB, and AB plus is giving us everything. Therefore, AB is a candidate key. So, we cannot get one element, and also two element candidate keys, only AB is there, right? Only AB is there is the two element candidate keys, right? So, why, you can argue that why can't we check CD? I don't check CD because I already written a point that every candidate key should contain AB. Therefore, every candidate key of two elements should also contain AB. But AB itself is making two elements. We cannot add anything to it. Therefore, there is only one candidate key with two elements, which is AB. Now let us see three element candidate keys, right? Three element candidate keys. Now we have A, B, C, D, E, right? Now A and B should definitely be present. There is only one way. And C, D, E, out of C, D, E, we need one more element, right? Out of C, D, E, we need one more element. Now try to understand this. If you go by listing them down, you will miss some of the combinations. So what I will do is, out of these three, we need only one of them, right? So I can write like this 0, 0, 1, which means I will take only E, right? So the problem is, you don't even have to do that. See this, AB is the candidate key, and every candidate key should contain AB. These are the 2 points. AB is the candidate key, and every candidate key should contain AB. So, to AB, if I add anything, either C or D or E, that will not be a candidate key. The reason is AB itself is already a candidate key. By adding it, it will become a super key, not a candidate key. Therefore, we will not get any three element candidate keys, right? Now, let us say 4 element. Again, the same logic. AB has to be involved. AB should be in the candidate key. And how many 4 elements? C, D, E are remaining. You have to choose 2 elements from it. But then even if you choose them, already AB is a candidate key. Even if you choose 2 members, that will become a super key, not a candidate key. Therefore, there are no 4 element super keys. Now, what about 5 element? In 5 element, you have to take everything A, B, C, D, E, out of which AB is already a candidate key. Therefore, this cannot be a candidate key. This will only be super key. Therefore, only one candidate key we get. We are not going to test all the 31 cases. We can simply solve it within 2 minutes. This is called RBR method. This is called RBR method, and please accept that RBR is God of computer science. Okay? And computer science is CS is
common sense.
good. Okay, with more problems you will be able to understand more. Okay, let's do one more question. We will see lot of questions, and tomorrow we are going to have marathon of PYQs. Okay, now relation R is A, B, C, D. Now the functional dependencies are AB determines C, C determines D, D determines B. Okay, now again the same logic you can apply. See what are the attributes missing on the right side. Out of A, B, C, D, C is there, D is there, B is there, right? But A is missing, right? So you can say that in order to determine A should be always in the left hand side of the determinant. Always the determinant should contain the A, right? Therefore, you can say A should be present. A should be present in every candidate key. A should be present in every candidate key, right? A should be present in every candidate key. Okay. Now check if A is a candidate key. Check if A is a candidate key. Check if A is a candidate key, right? Right. Now, how do I check it? I will do A plus. If I do A plus, I am going to get A, and after that, I am not going to get anything. See, if I have to get C, I should have B. I don't have B. I don't have C. I don't have D. I will not get anything. So, A plus is A. So, what does this mean? A should be present in every candidate key, and A is not a candidate key. A is not a candidate key, right? And A is not a super key also, right? A is not a super key also. Okay. Now see this. Now see this. Now see this. So, what are all the one attribute candidate keys? We have to find out what are all the one attribute candidate keys. And I told you that A should be present in every candidate key. Therefore, we are going to get A here. Now, you cannot make any other one attribute candidate key by including A. See, if I include A, there is only one possibility of getting one attribute candidate key, which is A, and A is not a candidate key, right? Therefore, if you write candidate keys here, one attribute candidate key is not there, okay? Now, let us see two attribute candidate keys. Two attribute candidate keys, and I told you that what are present here? A, B, C, D, right? A should definitely be present, and along with A, there can be one of these. There are three elements out of which you have to choose one element, right? There are three elements out of which you have to choose one element, which is nothing but three possibilities will be there. Now, if you write them down, don't write them down, because if you write them down, you will be confused. BC, BD, CD, right? That will be little bit confusing. So use zeros and ones. I will include B, I will not include these two. Or I will include, I will not include B, I will include C and 0. I will not include D. Now I will not include BC, I will include 1. Now what are the three possibilities we got? Right? So one is AB, and the other one is AC, and the other one is AD. Find the closures of all these and see if they are candidate keys. Now, if I look at AB, I will get, if I look at AB, I will get AB, and then because of AB, I will get C, because of C, I get D. So, I got ABCD. Therefore, AB is a candidate key, right? Therefore, two element candidate key is AB, right? Now you have to check AC also, right? So AC, using AC, I will get AC, because of C, I will get D, and because of D, I will get B. Now I am getting ABCD, right? Therefore, AC is also a candidate key, right? Now look at AD. Because of AD, I get AD. Because of D, I get B, and because of AB, I get C. So AD is also a candidate key, right? Now we have to check three element candidate keys, right? So A, B, C, D, right? Now let's take AB and let's not use AB. What happens if I use AB? If I use AB, the problem is that is already a candidate key, and so any combination with AB will become a super key. We want just the candidate keys. Therefore, I will not take AC. Now, without taking AC, there is no way I can make three elements, right? Therefore, three using by discarding AC, we are not able to get any three element set, so discard it. Now A, B, C, D. See, you have to watch this video 2 times. Okay, you can watch this video. Oh yeah, A must be included. పెద్దగా చెప్పండి రా, ఏం కాదు, పెద్దగా మీరు అక్కడ నుంచి చెప్పొచ్చు కదా, right? See, one thing that we have got is, I have to do a point here. పెద్దగా చెప్పండి. నేను ఎన్నిసార్లు చేసేటప్పుడు బోర్డు మీద చేసేటప్పుడు తప్పులు పోవచ్చు, పెద్దగా చెప్పండి. ఓకే, see, A, B, C, D, and we told that A should be present in every key. Okay, A is present. Now I have to make 3 element sets, right? So which means I have to choose 2 elements from this. 3C2, which means 3 possibilities we get. 3 possibilities we get. Now what we do is, don't write all the 3 possibilities. You just see, from these 3 you have to choose 2. So let us choose these 2, B and C, or let us choose B and D, or let us choose C and D, right? Now what are the things we get? We get A, B, C, but AB is already a candidate key. It cannot be the candidate key, it will be the super key, so remove it. Now what about this A, B, D, right? Now if you look at it, AD is already a candidate key, so it cannot be the candidate key. Now what is this? A, C, D. Now AC is already a candidate key, it cannot be the candidate key. Therefore, we don't get any 3 element candidate keys. Now what is the 4 element candidate key? 4 element candidate key is A, B, C, D, and definitely if you take all the attributes in a relation, that is going to be a super key, right? So now I will give you 2 minutes time, or let us say 3 minutes time. You rewind in this video, go back to where I started and watch it again, and I'm going to teach you one more problem. Okay, go back to the video, just go back in the video and watch it again. In one time you are not going to understand it. It requires a lot of intuition and practice. It is not so simple to understand. I made it simple, but still it is not simple. Go back, watch it, and again we will continue the next problem. I'm giving you 3 minutes of time. Okay, Okay, good. Okay, so guys, you understood this. Actually, we were supposed to test 15 cases, but we didn't solve all the 15 cases, right? We have eliminated many of them, right? So this will come with practice. You have to practice a lot. Okay, what was the question? A, B determines C, C determines D. Okay, fine. Let's do the next one. Okay, let's do the next one. So relation R is A, B, C, D, E. Okay, and the functional dependencies are A, B determines C and B, C determines D. Okay, now in the right hand side, A, B are missing and E is also missing. A, B, E is missing, right? Therefore, every candidate key should contain A, B and E, right? Therefore, you will not get. So let us test whether A, B, E is a candidate key. Let us test with if A, B, E is a candidate key. Let us test if A, B, E is a candidate key. Let us test if A, B is a candidate key, right? So you are going to get A, B, E, and because of A, B you get C, and because of B, C you get D. So A, B, C, D we got. Therefore, A, B, E is a candidate key. I'll write it here. Candidate key is A, B, E is a candidate key, right? And every candidate key should contain A, B, E. So it is clear that we cannot have any one element candidate keys. We cannot have any two element candidate keys, and only three element candidate key present is ABE. We don't have to test it. And now we have to go with four element candidate keys. Now A, B, E should definitely be present, and then we have C and D, right? C and D. Now these should definitely be present in every candidate key. Now how can I make a four element candidate key? I have to take this one or this one, but the problem is ABE is already a candidate key. Now if you try to add anything to it, that will become a super key. That is not a minimal candidate key. So we will not get any four element candidate keys. Now if you look at five element candidate keys, now already if you take everything in that ABE is present, so five element candidate key will become a super key, not a minimal super key, because ABE will be present in that. That is already a candidate key. By adding something you will get the super key, not the minimal super key, right? Therefore five element is also not there. So only candidate key we have is ABE. Only candidate key we have is ABE, right? Okay, now let's solve the next one. Solve the next one, right? Relation ABC. ABC is a relation. No non-trivial FDs. How many candidate keys are possible? How many candidate keys are possible? So, how many candidate keys are possible? Totally, you have ABC. How many candidate keys are maximum possible, right? So you can include A in the candidate key or not, B in the candidate key or not, C in the candidate key or not. 2 power 3 you get, subtract 1 from it, right? Why? Because null string cannot be a candidate key. Fan append. Because null string cannot be a candidate key. Null string cannot be a candidate key. So totally we will get 7. Okay, this is simple. Now this was asked in GATE. Okay, now a relation A, B, C, D, E, F is given, and the functional dependencies are AB determines C, C determines D, CD determines BE, CD determines BE, and DE determines F, DE determines F, and EF determines A. EF determines A. Now we have to find all the candidate keys. Okay. Now we have to find all the candidate keys. Okay. Now let's see in the right hand side if anything is missing. A is there, B is there, C is there, D is there, E is there, F is there. Everything is there in the right hand side. So this is going to be little bit complex. So where do you start? Now that everything is there, we don't have an initial point that something should be present in the candidate key, right? Therefore, we will start with one element candidate keys. Therefore, we will start with one element candidate keys. What are they? They can be A, B, C. No other option. You have to do all this. A, B, C, D, E, F. Okay. Now you have to find out A plus, B plus, C plus, D plus, E plus, F plus. Now what is A plus? I'm not going to get anything except A. Now what is B plus? I'm not going to get anything except B. What is C plus? Okay, I will get C as well as D, and because of CD I get B, right? And because of DE I get F, and because of EF I get A, and now because of AB I get C also. So I got everything A, B, C, D, E, F. Therefore C is the candidate key, which is a one element candidate key. C is a candidate key which is a one element candidate key. What about D plus? So D plus is coming D, and I don't think that you are getting anything else, right? And what about E plus? E plus is going to be, we are not getting anything. V plus we are going to get only E. Now what is F plus? F plus also we are not getting anything, only F, right? So one element candidate key is C. C is the one element candidate key. C is the one element candidate key. C is the one element candidate key. Okay, fine. Now let us see two element candidate keys. Let us see two element candidate keys. A, B. Be very, very attentive. If you miss it, you will not understand it. Be very, very attentive, right? A, B, C, D, E, F. Okay, A, B, C, D, E, F. And C is a candidate key. So if you want to make any two element candidate keys, you should not include C. Why? If you include C, that is going to be a super key, right? Right? Okay, so I will write C here, and then A, B, D, E, F. So you cannot include C. Let us put it as 0. Now what do I want? I want two element super keys, right? Now out of these 5 values, I have to choose 2 values. Out of these 5 elements, I have to choose 2. Now the problem is 5C2 is 10. We have 10 combinations. How are you going to write 10 combinations? It will be very difficult for you to take 10 A, B, B, D, E, F. You will miss out something, right? So you go by the way that I teach you, right? So if I have to choose 2 elements, I will put 2 ones, and whatever I don't choose, I will put zeros. So then what do you get? You get the combination, the permutations of 2 zeros and 2 ones and 3 zeros, right? Now just organize them so that you get all the 10 strings. Just organize them. See, what I will do is, I will first write all ones together, right? So it is going to be 1 1 0 0 0, or 0 followed by 1 1 0 0, or 0 0 followed by 1 1 0, or 0 0 followed by 1 1, right? Now I will separate one ones with one zero in between, two zeros in between, three zeros in between. Let me separate one with one zero in between. 10100 or 01010. I am separating ones with one zeros, right? And then 00101. So these are all the combinations I get when I separate with 1. Now let me separate ones with two zeros, 1 followed by 001 followed by 0, or 0 followed by 1 followed by 001, right? These are the two elements. I am separating ones by two zeros, right? Now I will separate ones by three zeros, 1 followed by 00001. That's it. So count all of them: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In exam you will do it very fast. While explaining it is taking some time. Otherwise in exam you will do very fast. Now what is this? C is not included, therefore AB. What is this? This is BD. What is this? This is DE. What is this? This is EF, right? Now what is this? This is AD. Now what is this? This is BE. What is this? This is DF. What is this? This is AE. What is this? This is BF. What is this? This is AF, right? So I have seen some YouTube videos where people are saying that find out one candidate key and then see what people are saying is, let us say AB is a candidate key, and if there is a C determines A, then you just write CB, replace A by its left hand side. But if I follow this method, you will fail in many examples. Everyone follows this method. Everyone follows this method and you are not going to get all the candidate keys. I will even take and prove examples that if you go by this method, you are not going to get all the candidate keys. This is the method you should follow, right? Now you have to find, see, since I am explaining it, it is taking some time, but if you do it, it won't take that much time. Okay. Now AB plus, BD plus, DE plus, all these pluses you have to find out, right? Okay. Now what is AB plus? AB plus is A, B, C, D, and then since D is there, E. So AB is a candidate key. AB is a F leda D, F, yeah. Okay. So AB is a candidate key. What about BD? BD we get BD, and then because of BD I don't get anything, so that's it. And what about DE? I get DE, and because of DE I get F, and because of EF I get A, and then B is not here, C is not there, and C is not there, so that's it, right? Now let us say EF plus. Now EF plus is going to be EF plus is going to be EF, and because of EF I get A, and then that's it, I guess. There is no B here, there is no C here, there is no D and C here, there is no D and D here, therefore that's it, right? Now we are going to find out AD plus, right? So how are we going to do AD plus? So we get AD, and because of AD we don't get anything. B, we get BE, and because of BE we don't get anything. And DF, because of DF we don't get anything. DEF, nothing. And then AE, because of AE we don't get anything. And then BF, because of BF we don't get anything. Yeah. And because of AF we don't get anything, right? So two element candidate key is AB only, right? Now let's move on to three element. Okay, you can make a notes of it. Anyway, Vasuda is going to provide you notes, so you don't have to write the notes. Okay, so now let's look at three element candidate keys. Okay, you should not erase it, actually this is required. This is required because later I will show you we are going to use these values. Okay. So we need 3-element candidate keys. 3-element candidate keys, and in those candidate keys C should not be present or AB should not be present, right? So this is something like A union B. C should not be present, AB should not be present. C should not be present, AB should not be present, right? Right? Okay, fine. C should not be present and AB should not be present. So love me or hate me, you can't ignore me. Someone has come to the chat and he's writing that there are so many fake chats in the chat. Okay, what do you mean by fake chats? Okay, if you think that it is fake chat and my class is not good, just leave the class. You are still watching the class, right? Love me or hate me, you can't ignore me. Okay, keep hating me. I really don't care. I just ignore you. You write any number of negative comments, it doesn't impact anything. Okay. ठीक है? So 3-element. So 3-element candidate keys. Now we have A, B, C, D, E, F, right? Now C should not be present. First, let's get the case where C is not present, right? Now, in order to make 3-element from these 5 elements, I have to choose 5C3. Again, there are going to be 10 combinations. Okay. So let me write it like this. C I will write here. C I will write here. Then A, B, D, E, F here. Okay. And C I am not going to choose. Right. And from these 5 elements, I have to choose 3 elements. Right. So from 5 elements, I have to choose 3 elements. So I will put 3 ones and 2 zeros, and I will just find out all the jumbles of it. This is a Mississippi problem, right? In combinatorics, Mississippi problem. It is nothing but 5 factorial by 3 factorial into 2 factorial, or you can also write it as 5C2 or 5C3, whatever it is, we get 10 combinations. Now the beautiful part is you don't have to analyze all the 10 combinations. I will show you. Okay. So first there are 2 zeros, right? Let's see all the zeros are together. 0 0 1 1 1, and then 1 0 0 1 1, and then 1 1 0 0 1, and then 1 1 1 0 0, 1 1 1 0 0. So all the zeros are together. Now I will separate zeros by 1 1. So 0 followed by 1 1 followed by 0 1 1, or 1 followed by 0 followed by 1 followed by 0 followed by 1, or 1 followed by 1 followed by 0 followed by 1 followed by 1. So zeros are separated by 1 1. Now separate them by 2 ones, right? So 0 followed by 1 1 followed by 0 followed by 1, or 1 followed by 0 followed by 1 1 followed by 0. That's it. Now separate them by 3 ones, 0 followed by 1 1 1 followed by 0. Now out of these, some of the combinations you can eliminate. See this contains AB. Eliminate it, right? The reason is AB is a candidate key. Any superset of it will become super key, not minimal super key. Now this also you can eliminate it. Now this also you can eliminate it, right? So 3 are eliminated. Now we have these only the cases are these. Now one is B, D, E, F, right? Now just check if D, E, F is already solved. Just check if D, E, F is already solved here. Okay. Yeah, D, E, F is not giving us the complete thing. So eliminate it. Now what is it? A, E, F. A, E, F. Now check here, A, E, F is already done. It is not giving us the all the attributes, therefore you need not worry about it. Now it is B, E, F. B, E, F, right? So check if B, E, F is already done somewhere. B, F is not done, right? We should check it. So B, F is going to be, I will write it here. So B, E, F closure. So BF closure is going to be BEF. EF determines A, and AB determines C and C determines D. A, B, C, D, E, F. We got everything. Therefore, three element candidate key is B, E, and F. Right? We got B, E, and F. Now, what about this one? This one is A, D, F. See if ADF is already tested here. ADF is already tested here. It is not giving us anything, so you eliminate it. Now what about BDF? BDF. Check if BDF is anywhere tested. BDF is not tested anywhere, right? So we have to do it, huh? So what is BDF plus? So BDF plus is going to be BDF, and then because of we are not getting anything, right? We are not getting anything. Okay, so this is also not a candidate key. Now what is this? ADE. ADE is this, right? So now if you look at this ADE, okay, ADE is here, so you don't have to check it. Now BDE, right? BDE. Now see if BDE is already done here. BDE is done, but BDE is not done. We have to check it. Now BDE plus is going to be BDE, and now because of DE we are going to get EF. Because of EF we are going to get, because of B, because of 1 minute, I lost the flow. Okay, so BDE, right? Now because of D we are going to get F, and because of EF we are going to get A, and because of AB I'll get C. So A, B, C, D we have got. So one more candidate key is B, D, E. B, D, E is one more candidate key. Now three elements are also done. Okay. So now let us see. So by eliminating A, B also we have to check, no? We have checked only by eliminating C. Okay. Okay. Fine. Now 4 element set. 4 element sets. Okay. So A, B, C, D, E, F. We need 4 element sets, right? So we cannot include C. Let us not include C. Okay, let me write C. C, A, B, D, E, F. Let's not include C and write down all the other cases, and then we can definitely eliminate some of them. Okay. So what is that? 4 elements. From 5 we have to choose 4, which is 5C, 1, which is 5. Right. Now we have to choose, we have to remove 1. From 5 we have to remove 1. So then I will have 1 0 followed by 4 ones. Now 0 followed by 1 2 3 4. 1 0 followed by 1 2 3. 1 1 followed by 0 1 1. 1 1 1 followed by 0 1. 1 1 1 1 followed by 0. Right. Now you have to check all this. What is this? B, D, E, F. Already that might have checked somewhere. B, D, E, F. So B, D, E is already a candidate key. Therefore, this possibility is not there because it will become a super key, right? Now here A, D, E, F. See if A, D, E, F is checked. A, D, E, F is already checked. It is not a candidate key. Now A, B, E, F. AB is a candidate key, so don't take it. AB is a candidate key, don't take it. AB is a candidate key, don't take it. So we are not going to get any 4 element candidate keys. Now let us talk about 5 element candidate keys. 5 element candidate key is only one, and that is okay. 1, 2, 3, 4, 5, 6. C we should not choose. Now we have A, B, C, D, E, F. If you choose A, B, C, D, E, F, already A, B is a candidate key and also there are other candidate keys. So this will become a super key. There is no 5 element. So the total number of candidate keys are 4. C, A, B, B, E, F, B, D, E. Don't worry, in exam they will not give you such a big question, but we are solving very big questions so that you will be able to do easy questions simply. In exam, questions will be very simple. If you follow this method, within less than 2 minutes you will be able to answer any gate question. But in the class I have taken big examples so that you will understand everything. Okay, see, actually how many are there? 1 2 3 4 5 6. If you have to follow the textbook method, you have to test 2 power 6 minus 1, which means 63 possible candidate keys you have to test. But if you use little bit of logic, you will not be, you don't have to check these many. Only few combinations you can check and you can declare. Okay, this all comes with practice. We are going to practice a lot of questions. Don't worry, I will give you 3 minutes of time. Just go back and watch this one and we'll solve the next question. Okay, I'll just give you 3 minutes. Okay, time and then 9:54 ఇంకొకటి సాల్వ్ చేద్దాం. ఓకే, అది ఇది క్వశ్చన్ రాయండి, క్వశ్చన్ రాయి. అక్కడ పెన్ ఉంది, ఆ పెన్ తీసుకొని క్వశ్చన్ రాయి. పైన పైన మళ్ళీ cool. Let's solve this problem. Okay, నిద్ర వస్తుందా? కుమ్మేద్దామా 11 దాకా? ఓకే, కుమ్మేద్దాం అయితే. కూల్. సో గైస్, ABCDEF, A B to E, C to D, E determines F and F. Okay, look at the right hand side. What is not there? A is not there in the right hand side, B is there, C is there, D is there, F is there, right? So A is not there in the right hand side. So you have to write this point. What is it? Every candidate key must contain A. This will reduce a lot of cases. Okay. Now let's find out if A is a candidate key. Now if I do A plus, I am going to get only A. A is not a candidate key, right? Now we will not get one element candidate keys because why do I not get one element candidate keys? Because A should be present in the one element, and if A is present, you cannot add anything. So one element possibility is A, and A is not a candidate key. Now let's do two element, okay? Two element candidate keys. Now A is there, B, C, D, E, F is there, right? Now what about the two element? So you don't have to write the numbers, it's very simple. A should definitely be there. So you have to write AB, AC, AD, AE and AF. Now find the closure of all of these, right? So what about AB closure? AB closure is going to give me AB, C, D, E, F. So A, B, C, D, F, all of them have come. Therefore, candidate key, one of the candidate key is AB, right? Now, what about AC? So because of AC, I get C, because of C, I get DE, and because of E, I get F, and because of F, I get B. So I got everything. Therefore, AC is candidate key. Now, what about AD? What about AD? So because of AD, I get AD, but we are not going to get anything extra. Here B is required, here C is required, E is required, F is required. Not. Now what about AE? I get AE, and then because of E, I get F, because of F, I get B, and because of AB, I get C. Therefore, AE is also a candidate key. And what about AF? AF, I have to write AF here, right? So I will do only functional dependencies on YouTube. For the rest of the DBMS course, you have to follow my paid lectures. Only today's lecture and tomorrow's lecture will be on YouTube, and the rest of the topics will be on paid platform. Okay, paid platform, right? Okay, fine. Two elements is done, and we got three. Okay, now we have to do three elements. Huh? Acha. AF determines AFB, and AB determines C. C determines D. So we got this also, AF. AF is also a candidate key. Now we want three elements, right? And A should always be there. Now what are this? B, C, D, E, F, right? They will not give you this big question gate, don't worry, okay? Now from these five, we have to choose three. So it is going to be 5C3, which is 5C2, which means 10 combinations we get. But don't worry, many of the combinations will get automatically eliminated. Okay. So A we have to include. Now out of these four, we have to take two, right? Which means we have to take two ones and three zeros. Now what do I do? Put all the ones together. Yeah, put all the ones together and then separate them by 1 0, separate them by 2 0, separate them by 3 zeros. Put all the ones together first, okay? 0 1 1 0 0, 0 0 1 1 0, 0 0 0 1 1. Otherwise, if you have to write them, you will get confused, okay? Now separate ones by 1 0, 1 0 1 0 0, 0 1 0 1 0, and then 0 0 1 0 1. Separate them by two zeros. So 1 followed by 0 0 followed by 1 0, or 0 followed by 1 followed by 0 0 1. Separate them by three zeros. 1 followed by 1 2 3 1. So we got all the 10 combinations, but most of them will get eliminated, right? So if you take this AB is present, right? So this cannot be candidate key because AB is already a candidate key. Now CD ACD. So A has to be 1. A has to be 1. 1, 1, 1, 1, 1, 1, 1. Now we are talking about ACD. AC is already a candidate key, eliminated. Now we are talking AE is already a candidate key, eliminated. Now we are talking about AEF. AE is already a candidate key, eliminated. Now we are talking about AB, D, and AB, yeah, AB is a candidate key, eliminated. Now we are talking about AC. AC is a candidate key, eliminated. Now A, D, F. AF is a candidate key, eliminated. Now AB again eliminated. Now AC. AC is a candidate key, eliminated. Now AB. AB is a candidate key, eliminated, right? So we are not getting any 3 elements candidate keys. Now let's see about 4 element candidate keys, right? So A should be there, B, C, D, E, F. From these I have to choose 3 elements. From 5 I have to choose 3 elements, which means again 10 possibilities. A has to be included. Now I have to choose 3, therefore 11100 I have to write all the permutations of it. Mississippi problem, 5 factorial by 3 factorial into 2 factorial, which is nothing but 5C3 or 5C2. Okay. Now you are going to put these numbers here. Okay. So let's put zeros together. 0, 0, 1, 1, 1. 1 followed by 0, 0, 1, 1. 1, 1 followed by 0, 0, 1. 1, 1, 1 followed by 0, 0. Most of them will get eliminated. Okay. Now separate zeros by 1, 1. 0, 1, 0, 1, 1. 1, 0, 1, 0, 1. 1, 1, 0, 1, 0. We have separated by 1 ones. Now we have to separate them by 2 ones, right? So 1 followed by 0, 0 followed by 1 followed by 0. Now, ante kada 3 ones kada. ఇక్కడ ఏంటి ఇక్కడ ఏదో పోయింది ఒకటి 1 separated by 3 zeros. 1, 2, 3, sorry, 0. 0 separated by 3 ones. 0 separated by 3 ones. Is it right? What is it we missed out? Actually, I have broken the flow. So, 2 zeros, see, 2 zeros are separated by 1, 1. Acha, one more combination where 2 zeros are separated, 2, 2, 0, acha, 1, 1, 0, 1, 0, right? Okay. Now, these 2 zeros are separated by 3 ones, 0 followed by 0. Is it right? Just check it. All the zeros are together. Zeros are separated by 1, 1. And zeros are separated by 2 ones is missing, right? Yeah. Zeros have to be separated by 2 ones. One minute. How I have lost the flow here. Okay. So what is the number that we are wanting? We want 3 ones and 2 zeros. Yeah. So zeros are separated by 2 ones. Right. So 0 are separated by 2 ones. Zeros are separated by 2 ones. Right. And these are the only two. So zeros are separated by 2 ones. Now finally zeros should be separated by 3 ones. 1, 2, 3. So totally we have to do it 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 we got. Okay. Now one thing is for sure. This is A, D, E, F. So AE is already a super key. So don't check it. Okay. Here we have AB, AB, AB. So you don't have to check all these 3. Right. And here 1, 1, AB, don't check. AB, don't check. AB, AB, don't check. Right. Now check this one. So we have AC. AC is a candidate key. And then we have AC. AC is there, right? AC candidate key. and then here also we have AC candidate key. So we don't get any 4-element candidate keys, right? Now finally we have 5-element candidate keys. 5-element candidate keys I will write here, okay? 5-element candidate keys. A should definitely be present. B, C, D, E. B, C, D, E, F. Now out of these 5 we have to choose 4, which is nothing but 5C1. We get only 5 combinations, right? So out of these 5 we have to choose 4, right? Out of these 5 we have to choose 4. 1, 1, 1, 1, 0. Now you put it 0 followed by 1, 1, 1, and then 0, 1 followed by 0 followed by 1, 1, 1, 1 followed by 1, 1 followed by 1, 1 followed by 0 followed by 1, 1, 1, 1, 1 followed by 0, 1, 1, 1, 1, 1 followed by 0, right? Now AC, it is already a candidate key. A, B, it is already a candidate key. A, B, candidate key. A, B, candidate key. A, B, candidate key. So 5 element are not there, and anyway 6 element is you have to take everything, and that is not going to be a candidate key because subset of its sum are candidate keys. Therefore that's it. Only 4 candidate keys we have. It is a very big example, that is why it has taken some time, but if you do it, you can do it in 3 minutes. But this kind of question, this big question will not be given in GATE. Okay, so I think we will end it here. So how many more problems are there? 3 more. చేసేద్దాం 3. ప్రస్తుతానికి 12 ఉన్నాయా? ఓ 2 ఉన్నాయి ప్రాబ్లమ్స్. చేసేద్దాం. Okay, so tomorrow we will solve more questions. Okay, tomorrow we will solve more questions. Okay, fine. Tomorrow we will solve PYQs and we will solve more questions. Tomorrow is going to be PYQs ka marathon. It may take 3 hours, but we are, I mean, even if it takes 3 hours, we are going to do it. Okay, tomorrow is marathon PYQs on candidate keys. Okay, thank you so much. ఇది ఎండ్ చేయాలి కదా.